All right, this is going to be page 1 of notes 18 of Calc AB. We're going to be talking about something called the average value of a function. And as you can see, I'm actually on a GeoGebra page. I'm not in the notes because I think that watching this kind of dynamically happen is the easiest way to sort of understand the concept. So the way that I always think about it is, if you've ever gone to around where I grew up, there were a lot of 7-Elevens, and you could go there and you could get a slushie. And so the slushy machine, they would turn it on, and you've probably seen them like in a deli or whatever. There's it's like a rectangular tank, and then they turn it on and it agitates it. And so the slushy is going like all over the place, right? So maybe this is a picture of that slushy. What we want to do is we want to talk about, so there's a total amount of slushy, right? So this is just cross section, but right now there's 9.23 of it, whatever of it, right? So 9.23. What we're going to do is we're going to turn the machine off, and we're going to let all of the slushy just kind of like settle down, right? But it's going to have to stay in the tank. So the vertical parts are going to stay. So what I'm going to do is I'm going to turn the machine off, and we're going to kind of like watch this happen. So notice the value, 9.23. So when you press stop, that value shouldn't change. I mean, it's going to settle down, but you have the same amount of stuff. So here we go. So I'm going to stop it here just to like kind of see what's happening. See, we stopped it and we lost some here, and where did it go? It filled up in here. And what's going to happen if we keep going is eventually it's going to become, I'm just going to go to the stop position, a rectangle. This rectangle has exactly the same area as the original, 9.23. It also has the same base as the original, which means that there's something going on, right? This height, the height of this rectangle, it's the same base as the original region. It's the same area as the original region. The height of this rectangle is called the average value of the function on the interval. It's the average amount of this function on the interval. So here, it's all like distributed all over the place, and it's a really interesting graph. Here, it's really boring. It's just a straight line, right? That's when the machine is off. So what we're going to do here, we're going to try to figure out what's the boring amount. When we turn the machine off, what's the height that we still get? That's called the average value of the function. So the average value of this function, this curvy function on this interval, is the height of this rectangle. All right, let's go to the notes and see. The notes are going to walk us through this a little bit also, because you gotta really like internalize it. If you internalize the idea, not bad. So let's see, average value of a function. I think it's a fun little thing. So we're talking about average value. So it's a y value. The average value, because the values of a function are y values, the average value is going to be a y value. It's the average y value. What does that even mean? All right, let's see. So I got to add up some stuff, so that's great. Let's see if I can like, so this is 5 by 3, 15. And then 2 by 3 is 6, 7, 8, 9. I don't know, maybe 10, like this was 7, 8, 9, because that's 3 of those. And then, I don't know, 1, 2, I'm going to say there's like 2.5 more, maybe. So 24, 26.5, I think. It's the integral from 1 to 6 of f of x dx. I think it's about 20, what did I say? 24, 25, 26. I think it's like 26.5. Okay, so now what we're going to do is we're going to draw a rectangle. We're going to turn the machine off, right? So the machine, as it currently is, you got these vertical lines that are just like trapping your slushy. Here's a vertical line, here's a vertical line. Vertical lines are going to remain the same because they're trapping the slushy. Turn the machine off. Let's see where it all settles down, right? So I want to find a rectangle that has a base of 1 to 6. So it has, this is its base. Same base. And then what I need to do is I need, the base is, I need 5 times the height, the y average, is going to be 26.5. So that's 5 point something. All right, I'm going to average it. 5 point something. It's 26.5 over 5. I should just make it 26 and it makes everything easier, but I'm not going to. 26.5. What's 1.5 divided by 5? That's, I don't know, 3/10, right? So 5 5.3. Let's go with that. I'm going to say that's like here. And then if I go across, it's like here. So this rectangle should have the same area, right? So this is a rectangle that is 5 by, I think that, I forget what I said, 5.6 maybe? 20, it can't have been that. I don't know, 5.3. I think I said 5.3. 25 and 1.5 is 26.5. 5 by 5.3. 5.3 is the average value of this function. Right? If we could add up all the y values of that function between 1 and 6, and then divide them by the total number of y values between 1 and 6, like how many y values are there, we would get 5.3. It's the average value. So this rectangle has a height. The height is the average value. This height is the average value of the function. So, average value is a y value, and it's just the average height. So here, like you can see, we got some exciting stuff happening. It's moving around. Somebody turned on the slurpee machine. I think I keep switching between slushie and slurpee. Similar products, maybe the exact same product. I don't actually know. All right, what do we got? So here, that's 3 by 5. So this is 15. Let's just say 17. I think the whole thing is 17. So I'm going to say the integral from 2 to 5 of f of x dx is going to be, I'm saying 17. Okay, so that means that I want to draw a rectangle, same base, so from 2 to 5. Here's my base. I want my rectangle to have a height of 17 divided by the base is 3 units long. So I'm thinking that y average, the average y value, is going to be 17 over 3. That's going to give me a rectangle that has the exact same area as this really interesting slushie machine. I'm going to turn off the machine and I'm going to draw its resting state. So 17 over 3 is 5 2/3, I guess. Is that true? Yeah. So less than 6. Yeah, 5 2/3. Okay. 5 2/3, maybe here, maybe here. Those are definitely not in a line. Here. This right here, if I fill it in, this is, all right, whatever, just go for it, right? It's not a coloring show. This, even though it's turning into a coloring show. Oh, I went beyond the line. Shades of kindergarten. Oh man, getting yelled at. You didn't color inside the lines. Never did. This rectangle has the exact same area. This rectangle is 5. It's not 5. Is 3 by 17/3. Has the exact same area. This is the slushie machine when it's off. So what we're finding is, how high is the slushie when we turn off the machine? How much is in there? So this height right here, 17/3, is the average y value on the interval from 2 to 5. All right, so now let's think about how we got that. Because we're gonna do a lot of work to get these. But if you look at how we got them in each case, we took the actual value, right? The definite integral. We took the definite integral, and we said that that was going to be the base, so the interval. So from 1 to 6 is our interval, times the average value. So here, to find the average value, if I wanted to write it a little more clearly, I would say that y average was the integral, so from 1 to 6 of f of x dx, divided by the interval, which is 6 minus 1, 5, the base of the rectangle. Integral divided by interval is how we can find this. And we did the same thing here. We said the integral from, where do we start? From 2 to 5. The integral from 2 to 5 of f of x dx. That's the total amount of slushie. And then we divide by the base of the machine, which is the interval, 5 minus 2. So this was the average value. That's what we're going to do. We're calculating the average y value. It's pretty neat. I mean, it's a really interesting concept. We're going to end up using it for a lot of things. So we're finding the average value. The average value is a y value. Keep that in mind. There is a confusing thing that I will never confuse you with, but you might find in textbooks that's a little confusing. The theorem that tells you that the average value exists, because mean is another name for average, the theorem is called the mean value theorem for integrals. I will never use this term. So I'm not going to use this because I think that's confusing. So if I say mean value theorem, you know that I am talking about slope of the secant equals the slope of the tangent, slope of the tangent equals slope of the secant, right? That'll be continuous on the closed, differentiable on the open. If that's the case, then slope of the tangent line definitely equals the slope of the secant line. That's what I mean when I say mean value theorem. This is sometimes called that. We're just going to call it average value all the time. We're going to say, find the average value. What's the average value? The average value is blah, do something with it. So it's going to be integral divided by interval. It's a very cool thing. I'll be back in the next video to actually probably do some problems. So see you there.